We're asked to write an equation that describes the relationship between the inputs and the outputs from the table, where the inputs are the a values and the outputs are the b values. So we're looking for an equation that when a equals 2, b equals 8, when a equals 3, b equals 12, when a equals 4, b equals 16, when a equals 5, b equals 20, and when a equals 6, b equals 24. So by analyzing the table, we need to recognize a pattern to help us write our equation. So maybe in this first column we recognize that 8 is 6 more than 2, so maybe we think the pattern is we take the value of a, add 6 to get the value of b. But if we try that rule, when a equals 3, 3 plus 6 is 9, which is not equal to 12, which means that is not the correct rule to write our equation. So let's go back to a equals 2 and b equals 8. Maybe now we recognize that 2 times 4 is equal to 8, so maybe we think the rule is we take the value of a and multiply by 4 to get the value of b. Let's test this when a equals 3. When a equals 3, we'd have 3 times 4, which does equal 12. When a equals 4, 4 times 4 does equal 16. When a equals 5, 5 times 4 is equal to 20. And when a equals 6, 6 times 4 does equal 24. So now we have a relationship that we can use to write an equation. One possible equation would be a times 4 equals b. We can also write this a different way though. Multiplication is commutative, meaning we can change the order of the multiplication and it does not affect the product. So instead of a times 4 equals b, we could write 4 times a equals b. And whenever multiplying a number times a letter or a variable, whether it's a times 4 or 4 times a, we can also just write 4a. When we write 4a, this means 4 times a. So we can also write the equation as 4a equals b. And we could also write these equations in the opposite direction, meaning if a times 4 equals b, it's also true that b is equal to a times 4. And if 4 times a equals b, then b is equal to 4 times a. And if 4a equals b, then b equals 4a. All these equations would be correct to describe the relationship between a and b. But let's say instead of recognizing a pattern of multiplication, you recognize a pattern of division. Meaning, let's say you recognize that 8 divided by 4 is equal to 2. So maybe you think the rule is b divided by 4 equals a. Well, let's try it when b equals 12. 12 divided by 4 does equal 3. When b equals 16, 16 divided by 4 does equal 4. 20 divided by 4 equals 5. And 24 divided by 4 is equal to 6. So we can write an equivalent equation in a different form using division. We could also write the equation as b divided by 4 equals a. For an equivalent equation, we can also write this division as a fraction as b over 4 equals a. A fraction bar means division. And of course, we can also write these equations in the opposite order or opposite direction. We can write this first equation as a equals b divided by 4, as well as a equals b over 4. However, we do need to be careful with division. Division is not commutative, meaning if we change order of a division problem, we do not get the same result, meaning b divided by 4 does not equal 4 divided by b. So all these equations would be correct to describe the relationship between a and b from the table. I hope you found this helpful.